Hey, this is Chad from GeoPro. I am going to go over some data that Noel sent me and see if we can process it and get some good obstruction data. Then we'll go through AeroDAT and demo that for you guys. So let's start by opening TBC. We're going to start a new project. Metric is the template. Hit OK. We're going to change the coordinate system first. You guys always work in UTM zone 51 north, WGS 84, datum, EGM 08 geoid model. Hit OK. And now we're ready to import some data. So Noel sent me these files. There's GPS files and total station files. So we'll import first the GPS. So if we hit import, and select all the GPS data, hit import. All right, so we're at the import screen. If we import it by the check marks, this is all the data that's going to be importing. You'll notice that some of the data isn't checked. This is either duplicate information or information that isn't needed. If we sort by duration, what we'll find is at the top are the base stations. So you guys sat on this point, 4 hours 59, 450, 333. We're going to send the longest one to RTX to get a base station coordinate. The other thing we want to check on the antenna tab is sort by heights. And we want to make sure that they're all 2 meters to bottom of antenna. Hit OK. Now what it's doing here in the background, it's uploading that base station file to RTX, which is a Trimble website. It's uploading it there and it's processing it, and it's going to send us back good coordinates. So that base station coordinate will be plus or minus a few centimeters. It'll be reliable and something that you guys can count on for your base station. So it'll just take a minute depending on your internet connection as it uploads it. So if we click over to the Process tab, what you can see is it's doing the RTX post-processing. So the file has been uploaded to the server. It's comparing it to other GPS base stations in the region and computing a final coordinate for it. So this will take a few minutes as it uploads it. That's a lot of data that it's processing, and it's moving pretty quick here, so we'll just give it a second. All right, so it's done processing. It gives us horizontal precisions, which are really good here. Horizontal precision is just over a centimeter and a half. Vertical precision is 2 centimeters. So this is about what we can expect. Multiple observations on that point to be within a centimeter or two. We'll say import. And now if we go back, if we expand the points dialog, we've got under the base station point, we've got several coordinates here. All these global ones are the autonomous positions that came with the GPS. They're only good to plus or minus maybe 10 meters. Local RTX is the one that we want to keep. So we will delete the junk ones and then hit recompute. We can close this process tab now. So here's a look at our data. The base station is here. You guys took a lot of rover shots. That looks really good. Looks like it's up and down a runway. And one thing we want to do is right click on properties here of this and say that this is control quality. It had it at survey quality, but we're going to use it as control. So just check on that little box and select control, and we'll double click here and close. The other thing we want to do, just as a quick sanity check here, is go to the View tab, select all the data, and export it out to Google Earth real quick. We just want to make sure that this is in the right coordinate system, and if it is, when this shows up in Google Earth, we'll actually be at an airport and it'll look correct. Great. So here we are at an airport. So we know that we've got the settings all correct. Next thing we want to do is import in the total station data. So if we go to Import tab again, or Home tab, and click Import, we're going to import in that DC file. We're going to keep the existing project definition because we know it's correct. This will sometimes come up with some warnings. We'll look at them here this time, but generally they can be ignored. On this screen, if we go all the way down the bottom, it's going to tell us what the errors are, and they're all related to those GPS files. So what happened was we imported the GPS files first, and then we imported the total station data. This is just saying, hey, you did it opposite of how we expected you to do it. No big deal, it can be ignored. And now if we look at the data, it's looking pretty good. You guys sat on some points, set GPS, sat on a point, backside at another point. You did just like we taught you. So we're in good shape here. Next, we're going to go to the Survey tab, and we want to process baselines. Gives one unresolved error. You can ignore that. Say yes, continue. Now, what this is doing is processing. So the base station ran the entire time, and then the rover went out and you did short observations with that rover. What this is doing is applying the accuracy from the base station to the rover. So it's post-processing it and correcting for those positions, and it's giving you centimeter level positions on those short observations you did with the rover. So it's processing all of the GPS files that we imported. Down here you can see it says finished 1 of 7. So as it runs through these calculations, that'll be finished. So we'll just give it a second here. Because the base station is collecting a GPS measurement every second, this data can take a while to process. It's a lot of data there, but I think in general 5 minutes at most, and you should be in pretty good shape. So there it goes. It's processed all of them. Done 72 measurements. If we sort by solution type, we're going to look for some problems here. Sometimes if a GPS observation is performed under a tree or something, you'll have an error that'll say that it's not a fixed solution. Fixed is what we want to see. Sometimes it'll say float. Float is not a good GPS solution. Or things like the horizontal or vertical precisions can be flagged. We don't see any of that here. Everything is in really good shape. So we'll hit save. Now we can see that there's a few flags here. These flags indicate some sort of out of tolerance error. So if we click the point, close this here, click the point and say properties, and then hover over this flag, it'll tell us what the error is. The errors are all related to vertical tolerance, meaning you guys shot this point with GPS, and then you set on it with total station, or use it as a back site, and at some point, the two data sets didn't match up. So 0.16 there. So a little bit of that indicates that there was a backsite height error most likely, that you guys entered an incorrect height for the base station, or I'm sorry, for the rover or the total station. So the backside or the total station, one of them, it looks like may have an incorrect height in it. But generally these types of errors, if they're small, they can be ignored. In this case, you really want to pay close attention and make sure you get those errors eliminated, or try to figure out the cause of them. But looking at the data, I think it looks pretty good. What we want to do now is identify what points you have here. So if we select 2007, okay, 2007 is your end of runway threshold. Let's come down here. 2007 is your threshold. 2008 is also a threshold. Maybe that's a future threshold. And then 2006 is another threshold. So I don't know exactly which one is right. We can do this by doing a quick view in Google Earth. Let's see which one. So 6, 7, and 8 looks like they may be doing a runway extension here possibly. Let's check and see. What is 5? 5 also looks like a threshold. So let's use that one. We're going to say 2005 is your end of runway. We're going to rename it because 3000s are always end of runways. We will call that point 3001 because it's runway 01. At the other end, let's see. The other end, you have something similar with 1038. It's a runway shot. 2001, threshold 19, threshold 19, threshold 19. So again, there's a few more points there, but we're going to use this one. So we'll call this 3019. Now, what we want to do is export these 2 points. These are our end of runway shots. Home and export. And what we can do is point easting northing elevation code. This should be, I think, in your guys' export format. Easting is X, northing is Y, elevation is Z. So this is essentially exporting point XYZ description. We're going to pick the folder that this is going to go to, and we're going to call this runways. Hit export. So if we look in Noel's data, we have the runway shots. Those are just, open it in Notepad. It's just the 2 end of runway points. Next, we want to export out the centerline profile information because it looks like you guys have some in here. So points like 1052, 1051, 1050, 1049, 48, 47, all of these look like centerline profile shots. So let me close this and I'll select these. So 52, now I'm going to hold control, I'm going to click these, 1051, 1050, 49, 48, 47, 46, 45. That looks like they change in numbers. So 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, and 38. So we're going to export these out now. Same format, we're going to call it this directory here, centerline. Hit export. Next, we want to export out the obstructions. So if we go down here and look at these 5,000 points here, there are several in this area. Let's just drag and drop, select all of them. We'll hold control to unselect. We don't want any of the 2000s, 3000s. We just want the 5000s you guys have here. Slope 5032. So you got a bunch of obstructions there. We'll export these. Again, same format, and we'll call these obstacles. Now, looking at the exports directory, well, what we need is the runways. At a minimum, we need runways and obstacles. Centerline data is an added bonus. I'm glad you guys collected it. So let's open up AeroDAT. And we're going to first import in, we can do it two ways. We can go this way. In fact, let's go this way. We'll import runway ends. This is a custom version for you guys. You always work in WJS84 and you always work in UTM Zone 51, so hit OK. We're going to import in the runways. As I said, we exported these formats in .xyz description, so this is correct. Hit OK. And there it goes. It draws the runway in. As you can see, it looks really good. It's the yellow runway is the center line. Shows up in the right place. Next thing we want to do is import in centerline points. Again, .xyz description, hit OK. Imported those in. And then we're going to import obstacles. Same thing, hit OK. Handful of points down there. We can mouse over it and it tells us what point it is. Gives us the description. Now, what we want to do is go under expand runways and right click, say add analysis. Now the ICAO Annex 14 is in this program, all of the runway types. So if you look, I have Annex 14 open here, page 4-6. This is the approach runways table, table 4-1 of ICAO Annex 14. As you can see, there's a different runway classifications in here. Non-instrument 1, 2, 3, 4, non-precision 1, 2, 3, 4, precision 1, 2, 3, 4. Same thing in this program. So under the Add Analysis tab, you have non-precision 1, 2, 3, 4, non-precision 1, 2, 3, 4, precision 1, 2, 3, 4. So you're going to have to decide or talk with the airport, figure out what the runway code is, and then select that for the runway. Looking at this airport, it doesn't look like it's precision, so we're going to go with non-precision type 4. This may or may not be true. You can mix and match, but we're just going to pick one. You guys can pick any one you want. When you hit OK, it draws that surface in there. It uses the runway information that we imported, the runway centerline information we imported, and draws that runway, or that approach surface in there, the whole conical surface. Everything's in here now. Now, what we can do is, all right, if we expand, let me make this bigger here. If we expand the runway, there is the ICAO Annex 14 non-precision approach type 4, and it lists all the obstructions. There are 13 in the approach surface. What we can do is open the data table, and it will give penetration amounts. So 0.5004 penetrates by 10.85 meters. Gives the other ones as well. And then there are other points that don't penetrate at all. They're outside the surfaces, such as the primary surface. So I'm going to open up just the primary table and see how those penetrate. We can also, if we want to look at, say, the approach, right click and say view cross section. We zoom in. We may want to increase the exaggeration. See the approach. The other thing we can do, if we go back to the map, now since we've added surfaces when we hover over it, That's not right. What we want to do here is save some of these results out to AutoCAD or a spreadsheet. So if we open up, let's do this. Let's look at this surface and we will say open data table. We can say, we can filter by only obstructed, only inside, or all obstacles. Well, let's show us only obstructed. So the list is updated. We only get points that are obstructed. We can export this out then to a CSV. Let's do that. Let's say obstructions analyzed. We open that table up. It's really nice. Now we have the point, the X, Y, the Z, in the description and the penetration amount. We can look at specific surfaces, open up that data table, and see only those points in that surface. Horizontal surface, for example. All the points are well below the horizontal surface. So there's a lot of information here. We can also, you'll notice up here, we can switch over to different types of views, map view, and we can save this to an AutoCAD. So we'll call this AutoCAD. When it loads up, let me finish this here. Let's see, is it done? Oh, there it goes. So there it goes in AutoCAD. It gives us the drawing very nicely. Points are in there. And we can even look at it in 3D. So, really nice. And that's it. So I hope this video has been helpful for you guys. I'm going to upload this now to YouTube, and let me know if you have any questions.